So, a couple of guys have asked about the motor mount that I put onto my Ozark Trail Pro Angler 12. Um, so, what I did is I went out in the garage and I shot the best video because it's installed and tried to get some extra shots and some of the pieces I used for templates and stuff like that. And did the video or the audio also with it. So, hopefully, what you're about to see is of some help to you guys that have an Ozark Trail Pro Angler 12. It's a great boat, so it's a lot nicer when you add a motor mount. You can stick your electric motor on it. So anyway, I hope this helps. We'll see. Thanks. Okay, just for edification, these pictures are just quick pictures of the pieces as I was building the motor mount, getting the angles right and adding the back, the upright portion to it and all of that. And then I've also got some pictures here of the hatch that I put in. I got the hatch off of Amazon, and also of the bilge pump, 750 gallon per hour bilge pump, and then the associated hosing and stuff that you need to attach it, the drain hole and all of that. Okay, gang. A few of you are asking about my motor mount and how I made that and rigged it up. I'm sorry it's black, so it's kind of hard to see. But it's basically 1/8 inch sheet metal. So there's a piece here, and I'm going to drop one of my templates. Hang on. A piece here, a piece here, a piece on the back side, back here, and then a piece on each side. And those are all welded together, okay? I started with just basic sheet metal. And what I did, and I've got another picture of this bear where I had taken everything off, including the handle, or I took the handle off so you just see the boat form itself. But the first thing that I did was, when I got that handle off, I made a paper template. So I just laid paper in this position, and I just used a black marking pen. You can probably see the residual marks on the edges. And I just traced that indentation with regular paper, 8.5 by 11 sheet of paper. And then I calculated that I wanted to add a 1/2 inch in length to it, because 8.5 by 11, that's the 8.5 you're looking at. So I calculated I wanted to add a 1/2 inch to it. All right. And then what I did was I created a cardboard form. So you can see what it looks like here. It's just the same pattern as the paper, and then I added the side plates, right? It's just taped together. It's nothing fancy, real simple. And I left this open on the top because I wanted to put a 2x6 inside to mount the motor to. It would be steel back here and on the two sides, but I wanted to put 2x6 inside for a nice wood mount. Anyway, once I did that, then I basically had the angle, what that rear angle needed to be, right? And I also needed that front angle from this piece as it sloped down to here. So then, in order to get that, I just built myself a little plywood form. It's what, 3/8 inch plywood? And it didn't have to conform on the sides, I just needed the angle. So I cut a piece, fit it in, and then I cut another piece and I cut the angles and just slowly fit it right in here, the two angles. And then I just tacked it with a nail gun just so that it would hold. And I wanted this as a welding form so that when I went to weld these two pieces, this helped me keep that angle, that form, that shape. So that's all this was for, basically. Now I've kept those, all three pieces. I don't know why I have. I guess for moments like this when you guys ask questions and want answers. So once I got all that welded, all I did was paint it. I just used some roll bar paint that they have at O'Reilly's. It's great paint. It goes on nice and smooth and it looks really good. And then I went ahead and I put the handle back on because I do like to have something to grab this when I'm putting it on and off the cart. So I left the handle on there. I used the same holes, just drilled through the steel to meet it up. And I added a screw here, or a bolt here, and another bolt here. And I used stainless steel wherever possible because long term it's just a lot better. It doesn't get corroded and all of that stuff. Then I put 2 more bolts in down here, bolts and nuts. Now in order to access that, in order to get those nuts on the back side, nuts and washers on the back side of this thing so the mount was solid, I did have to add a 6-inch hatch. Now a lot of guys may say, oh geez, don't do that. Why do you want to cut into your boat? And basically I thought about it and I thought, you know what? I'd like to know when there's water accumulating inside the hull and there's no windows in this thing so you can't look down inside in the air pocket. So I thought usually the water is going to go to the back, at least when you pull it up on the beach, you know, and you need some way to find out whether there's water collecting in there. So I thought, you know, there's an advantage to a hatch. So I'm going to go ahead and get a hatch and add the hatch just for the fun of it. And I'm kind of glad I did because number one, it makes it a lot easier to put the nuts in for this mount, right? One there, one there, one here, and one here. And with the hatch, once I was done and I had that hatch, I also was able to stick a 750-gallon bilge pump in there in the back end. And it's in there nice and solid. It's not going anywhere. And I ran the hose from the bilge pump inside and up to this side and over here. And that's where I put my drain plug, is right over that Ozark Trail little mountain decal. So it shoots out at an angle away from the boat and it works really good. It's a good angle. I didn't want to, you know, I thought about putting it back here, but the surface isn't flat enough. I thought about putting it here, but it's not angled enough away from the boat. And this just gave me the right thickness right in here, this area, and it's close enough to that pump. So now I've got my motor mount made. I was able to mount it by cutting the access hole. I was able to fix the access hole by putting the hatch in, and because I now have the hatch, I can not only see water, but I could also install that 750-gallon per hour pump, or 750-gallon, per hour pump. So it worked out just fine. You do have to use sealant on this thing, and you want to make sure you use the silicone sealant, put it all the way around nice and thick so it fills these ribs. It's kind of ribbed in this area. So you fill those gaps and you get a good sealant. And then with the rubber gasket on these things, it's watertight. It's just dandy. So it works out really good. I can also throw, a rag, or I normally have a sponge just to clean up the deck when it gets wet. I just keep the sponge down in there over the top of this thing. It doesn't block the pump from working or anything. It's just a convenient place to lay that sponge when it's not in use. And then I always have access to it also. So that's what I did for the motor mount. You can see the 2x6 in there. You can see I did put bolts in through the 2x6. I recessed or countersunk the bolt head on this side. And then just because I didn't like the looks of the plain wood and I never stained it, I cut a piece of scrap plastic that I had laying around and I just screwed that in. That covers the bolt holes and it gives it a nice kind of black finish to it. And the motor mount's on there solid. I mean, this isn't going anywhere. I could lift this whole boat with this motor mount. Now, a guy could probably make something like this out of plywood, but you're still probably going to have to drill through the boat and be able to get in there and put nuts on the back side. So I wanted steel because I didn't want wear and tear, I didn't want dry rot, I didn't want all that. And I did take this faceplate down on here because of the weight and the thrust of the motor and forward and reversed will tend to rock this thing. And I wanted that to make sure that if it was pulling back, that it was not only pulling up here, it was mounted tight here on this flat surface, but that it was also mounted tight on this facing surface here. So all of that torque across this steel plate is now distributed between this surface and this surface down here, which puts less stress on the boat anyway. So that's what I made. That's how I made it. It works out pretty good. The tilt is really simple. It's a couple of strings I can pull from up front. I pull this one and it unlocks the motor. You can see it pop loose. And then I can pull it up with another string and it just slides up and basically locks in place. And then when I want to put it down, I just pull on another cord that pulls that line tight from the lock. This is the lock bracket. This line pulls it tight when I pull forward on the motor, loosens the lock. You can see it come up there, and then it'll drop right back down. And the swing of it, the weight of the electric motor itself, will push it right back in place and it locks tight. So that's how that works. For the steering, I don't know if you recognize this or not, but it's this piece right here. I didn't custom build it. I got it out of a Harbor Freight tap and die set. In fact, I had both the SAE and the metric set. I figured I only need one wrench, so I used the second wrench out of one of those two sets, just cut the flange off on the inside and smoothed it out so that it would fit over this, and then just screwed it into the back of the pipe. I just drilled and tapped it right there, right on the inside under here. So this is now on there solid. It allows me to run my lines right here for turning. And I put the springs on there just so that it's an automatic return to center. So that's how that works. Anyway, that's about the best shots I can give you and the best explanation I can give you for this motor mount. It looks good. It's totally functional. Haven't had any problems with it. So I hope this helps a little bit. Obviously, you can take the motor off. I've used clamps and the carabiners in various places to attach everything, and they just allows you to